Hey, so this is the video about time zones and how that's affected by longitude. So remember, when the sun is directly overhead, that means that's a certain time for you. We call that time solar noon. But solar noon for you, that's going to be a different time for someone else somewhere else on the world because the sun's not directly overhead for them. So if you've ever had friends or family who live, say, in different part of the U.S., like on the West Coast, you know that their time there is not necessarily the same time as it is over here. Or if you'd ever traveled internationally, you know, the same thing. There's a difference in times depending on where you are. And it's because the sun is either directly overhead or it's not, depending on where you are. So for example, this diagram right here, here comes the music to start the day. Okay. Well, I'm going to talk over it. So, where was I? Oh, yes. So, when the sun's directly overhead, it's noon for you, but that's not the case everywhere on Earth because the Earth is rotating, right? So, this would be the sun. So, sun would be directly overhead this part of the world, but not over on the other side. And as the Earth rotates, the sun will be overhead different spots. All right, that music is real distracting. We're going to pause this and come back. All right, and we're back. So this little diagram right here represents looking down at Earth from the North Pole. So like looking from this perspective down at Earth as the Earth rotates. So the Earth rotates counterclockwise, which will be something we've got to know in order to tell the times. So if you're right here, you are directly underneath the sun, or the sun is directly above your head. So that's going to make it 12 p.m., 12 noon. Well, as the Earth rotates, now if you're over here, the sun is you're right on the night-day line. Right? So the sun is setting, and this is going to make it 6 p.m. And as the Earth continues to rotate, if you're over here, this is going to make it, you're on the night side of the Earth, it's going to make it 12 a.m. And as the Earth continues to rotate right here, you're on the night-day line, but you're rotating back into the day, so it would be sunrise, 6 a.m. So there's a lot of info here, but really what you got to remember is that each time zone is 1 hour or 15 degrees of longitude. That's the key. So just to simplify all of this stuff here, you'd say one time zone equals 1 hour, which is the same thing as 15 degrees of longitude. So let's practice telling some times. So as you go west, time gets earlier by 1 hour, and as you go east, time gets later by 1 hour. And that's kind of tricky to understand, so we'll do a little bit of a visualization. So here's my sun shining on Earth. Now, the Earth rotates from east to west. That's basically what counterclockwise is. It's from east to west. So if we are right about, make sure you can see, but we're right about, here's North America, so we're on the east coast of North America, so over here, the east coast. So we are going to be rotating into the sun before the west coast rotates into the sun. So that's because the Earth rotates from east to west. So we have sunrise, but when we have sunrise, the sun has not risen yet in the west. So it could be like 6 a.m. sunrise in the east, but maybe it's 3 a.m. in the west. And as the Earth continues to rotate, now the west coast has their sunrise. We've already had ours, though, so time is later for us, and it's earlier for those people in the west. So maybe by this time the sun rises for the west at 6 a.m. there, it might be like 9 a.m. over here. So this little diagram kind of sums it up really nicely. As you go east, time gets later by 1 hour, and as you go west, time gets earlier by 1 hour. And that 1 hour is for every 15 degrees of longitude. Right? So if you go 30 degrees of longitude, that's another hour later if you're going east. So if you want to find the time differences, you basically just have to find how many degrees of longitude the spots are different, and then that'll tell you how many hours different they are. So step 1, find the change in longitude between two spots. So for this example here, it's 5 a.m. in California, and what time is it in New York? So the first thing is just find the change in longitude. So for California, we've got, that was 120, and New York is 75. So we can just do a subtraction and find the change. So 120 minus 75 gives us 45 degrees of longitude. Now, since every 15 degrees is 1 hour, we just divide, and that gives us 15, or that gives us our 3 hours, 3 hours difference. Because 15 goes into 45 3 times. So 45 degrees divided by 15 degrees gives us 3, and then it's 3 hours because every 15 degrees is 1 hour. So it's going to be 3 hours, but earlier or later? Well, okay. We want to know what time it is in New York. Now, New York, so if you look at a map of the U.S., here's my little sketch map of the U.S. It's not great. Right, there's Florida. Okay, here's Texas. Okay, little sketch map. So New York is over here. California is over here. So New York is east of California, which makes the time later. And we just said it was going to be 3 hours different, so it's 3 hours later. 3 hours later than 5 a.m., 8 a.m. So it's kind of tricky, but the first thing you're going to do is just find the change in longitude, divide by 15 degrees to get the number of hours difference. And the second thing you're going to do is just figure out if it's east or west of you. So let's try one up here. Let's say it's 12 o'clock noon in New York. If you go 30 degrees west, what's the time? Well, remember every 15 degrees is 1 hour. So 30 divided by 15 is 2. So it's 2 hours difference. And since we're going west, time is earlier. So 2 hours earlier than noon is 10. If you go 45 degrees east, so divide 45 by 15 to get, because every 15 degrees is 1 hour. Here's a bell. We got new bells this year. I like them better than the old ones. So divide 45 by 15 and you get 3 hours difference. And since we're going east, time is later by 3 hours. So 3 hours later than noon is 3 p.m. All right, and this last one here just wants to know how many degrees of longitude are these guys apart from each other if you know the time difference. So if you know your time difference is 6 hours, and each hour is 15 degrees of longitude, it just becomes 6 times 15. And they're 90 degrees of longitude apart. So that's how you tell time zones. And then try a couple of practice problems. Let me know if you've got any questions.